Grade 11 and 12 learners, welcome to the Scienceless channel. This is a continuation of our lessons in mechanics, Newton's laws of motion. So here we'll be looking at lesson 2, where we study different types of forces that we have. Generally, we have two types of forces: those that are contact and the ones that are non-contact forces. So I've divided this lesson into two, the categories of forces, into two lessons. So we'll first look at the contact forces, and in the next lesson, lesson 3, we'll look at the non-contact forces. Now, the contact forces are those type of forces that objects would exert on each other by physically touching each other. So objects here interact with each other by literally touching each other. So these include examples such as the tension, the normal force, and frictional forces. So there's only 3 of these contact forces that we're going to study. So I'll go to the first one, tension. Tension is a type of force that is exerted by objects that can stretch. Stretchy object, the force that you get in the stretchy objects. Now, these objects may include examples such as strings, springs, ropes, and so on. There are many different types of these objects. Let's say we have a wire, just to do an example here. Let's say we have a wire. Just want to use a blue pen here. Let's say we have a wire and this wire is sitting like this, right? So obviously object that can stretch will be elastic. They will be able to bend, easily and all that. Let's say you have it like this. And suppose now on this object, we actually really pull this object with forces that go in these directions. Remember, we said that a force is a push or a pull. So let's say we pull this wire in these two different directions. What would happen with this wire is that it will then stretch. It will then stretch as a result of those two forces, thereby giving us a force that goes in that direction and a force that goes in that direction. Now, the symbol for tension is the letter T, capital letter T, right? So here it means I will have tension T1 and also tension T2 to denote that we have one tension that goes in that direction and the other tension that goes in the opposite direction. Now, one thing that I wanted the objective of me doing this diagram and trying to explain this is that at our level in high school, in grade 11 and 12, we always assume that the tension is the same on every stretchy part of the object. So what do I mean by that? We assume that the tension T1 is the same as the tension T2 in magnitude. Meaning if this is 5 here Newton, also this has to be 5 Newton, right? They may point in different directions, that's fine, but they are both 5 Newton. We always assume that. Now you would realize that in reality this may not necessarily be the case. If you were to pull a string, these two forces may not be the case, right? So but at your level we don't study such scenarios where that is not the case. Now this is very important for us to understand, because if you were to have, let's say, two boxes attached on this string, right, you'll realize that these two boxes will have the same tension, right? This box here will experience this tension here because it's going in that direction, and this box here will experience this tension here because it's going in that direction. But the two tensions are the same in magnitude. We can give them a letter T to say they're the same magnitude T, maybe 5 Newton, as I've given an example there. But we'll get to a point where we solve this problems of this nature. But I'm just preparing you to say now the tension will always be the same along the string when we work with tension. Another force that we have that's a contact force is the normal force. Now I just want to talk a little bit about what the normal force, what the word normal, where it comes from. So the word normal in mathematics, it means 90 degrees, right? It means perpendicular, 90 degrees. Let me just write 90 here. It means 90 degrees. When we say normal, oftentimes you'll be working with normal lines. Those are lines that make an angle of 90 degrees. So when we say a normal force, it means it's a force that makes an angle of 90 degrees. So normally this is a force that is exerted by a surface on an object at an angle of 90 degrees, right? Remember, 90 degrees sometimes is called perpendicular. That is another word that you might need to know, or you can write it as 90 degrees, right? So the symbol for the normal force is sometimes used as a capital letter N. Some books they use small letter n, some books they use f, and then they use the subscript n, right? So it's up to you which symbol you want to use to represent that force. So let's just look at an example of how this force comes about. Let's say we put a box on top of the table, right? This box, you'll notice that it doesn't fall downwards. The reason being is because the surface of this table here actually supports the box by exerting a force that goes vertically upwards like that. It pushes this box, the surface of the table, it pushes that box with a force that goes vertically upwards, called the normal force, because this force is directly vertically upwards, making an angle of 90 degrees with the surface of the table. And then we call this force the normal force. So normal force usually will exist between surfaces when they push each other, right? So as an example in this situation here, that's how you will represent the normal force or spot the normal force, right? Always it has to make a 90-degree angle.